National Electrical Code, specifically Section 220.3b5, addresses the calculation of electrical loads for outlets serving heavy-duty lampholders. Although the term lampholder might seem ambiguous in this context, it refers specifically to lighting fixtures designed for demanding applications. These heavy-duty fixtures are commonly found in industrial and commercial environments where high levels of illumination are essential for safety and productivity. Think of spaces like warehouses, manufacturing plants, gymnasiums, sports arenas, and large retail stores. These areas often require lighting solutions that go beyond typical residential or light commercial applications. The key characteristic defining a heavy-duty lampholder, as it relates to the NEC, is its volt ampere, or volt, rating. According to the code, outlets for heavy-duty lampholders must be computed at a minimum of 600 volt amps. This means that when calculating the total electrical load on a circuit, each heavy-duty lampholder outlet must be accounted for as contributing at least 600 volt amps regardless of the actual wattage of the lamp installed, provided the lampholder is rated for it. This minimum volt ampere value ensures that the circuit has sufficient capacity to handle the demands of these high-intensity lighting fixtures, even if they are not operating at their maximum rated wattage. Several types of lighting fixtures typically fall under the category of heavy-duty lampholders. One common example is high-intensity discharge, or HID lighting. HID lamps are known for their high efficiency and light output, making them ideal for large open spaces. Common types of HID lamps include metal halide, high-pressure sodium, and mercury vapor lamps. These lamps often require specialized ballast to regulate their current and voltage, which contributes to their higher volt ampere requirements. Fluorescent lighting fixtures with high output lamps also fall under the heavy-duty category. While fluorescent lamps are generally more energy efficient than incandescent lamps, high output versions are designed to produce significantly more light, and thus draw more current. These fixtures are often used in industrial settings where bright, even illumination is needed. Light-emitting diode, or LED, fixtures with high output LED are also considered heavy-duty. LED have become increasingly popular in recent years due to their energy efficiency and long lifespan. However, high-output LED fixtures designed to replace traditional HID or fluorescent lamps can also have significant volt ampere requirements. These fixtures often incorporate sophisticated drivers to regulate the current and voltage supplied to the LED, and the overall power consumption can easily exceed the 600 volt amp minimum threshold. Now, it's important to clarify that not all lighting fixtures are considered heavy-duty. Standard incandescent and compact fluorescent fixtures commonly found in residential and light commercial settings typically have much lower volt ampere requirements. These fixtures are not subject to the 600 volt amp minimum calculations specified in NEC section 220.3b5. To determine whether a particular lighting fixture falls under the heavy-duty category, you need to consider its volt ampere rating and intended application. If the fixture is designed for high-intensity illumination in an industrial or commercial setting, and its lampholder is rated for 600 volt amps or more, then it should be treated as a heavy-duty lampholder for load calculation purposes. The NEC provides guidelines for calculating electrical loads to ensure that electrical systems are safely and reliably designed. When calculating the total load on a circuit that includes heavy-duty lampholders, it's crucial to adhere to the 600 volt amp minimum requirement. This ensures that the circuit has sufficient capacity to handle the demands of these fixtures, preventing overloads and potential fire hazards. In addition to the 600 volt amp minimum, it's also important to consider other factors that can affect the load on a circuit, such as the voltage, the power factor of the lighting fixtures, and any other equipment that may be connected to the same circuit. The power factor is a measure of how efficiently the electrical power is being used. A power factor of 1 indicates that all of the electrical power is being used to perform work, while a power factor of less than 1 indicates that some of the power is being wasted. Lighting fixtures with low power factors can draw more current than fixtures with high power factors, which can increase the load on a circuit. Therefore, it's important to consider the power factor of the lighting fixtures when calculating the total load on a circuit. The National Electrical Code provides detailed information on how to calculate electrical loads, including specific requirements for different types of equipment and applications. It is essential to consult the NEC and other relevant standards when designing or installing electrical systems. It is also important to consult with a qualified electrical engineer or contractor to ensure that the electrical system is properly designed and installed. Failing to do so can result in unsafe conditions and potential fire hazards. In summary, NEC Section 220.3b5 specifically addresses heavy-duty lighting fixtures with lampholders rated for 600 volt amps or more. These fixtures are commonly found in industrial and commercial settings where high levels of illumination are required. When calculating the total load on a circuit, each heavy-duty lampholder outlet must be accounted for as contributing at least 600 volt amps, regardless of the actual wattage of the lamp installed. It is also important to consider other factors that can affect the load on a circuit, such as the voltage, the power factor of the lighting fixtures, and any other equipment that may be connected to the same circuit. By following the guidelines provided in the NEC and consulting with qualified professionals, you can ensure that electrical systems are safely and reliably designed.